Hello, today I'm making a video about how to run an artificial neural network model in Python. Now, in terms of an artificial neural network model, this is a type of econometric model. Well, I say econometric, but this really have its roots in, like, let's say, data science and so forth. Now, this is a model that can be used to forecast. It can get input and can forecast output. It is advantageous over traditional time series models because the traditional time series models are based on the assumptions of linearity and normality and so forth. But we know in real life, when dealing with empirical data, the data is often non-linear. It is often not normally distributed. So as a result of these limitations, we tend to shift towards non-linear models. When we are using non-linear models, one of the types of models you use very commonly, frequently, is called an artificial neural network model. Now, an artificial neural network model is a computational model inspired by the structure and function of human's brain. It is used for various machine learning tasks, including pattern recognition, regression, classification, and forecasting. Artificial neural networks, also called ANNs for short, consist of interconnected processing units called neurons or nodes organized into layers. These layers typically include an input layer, one or more hidden layers, and an output layer. So there's roughly three layers. There's one input layer that receives the data. There's a hidden layer which does the processing and so forth, trying to find what the pattern in terms of the trend, whatever pattern in the data and so forth. And then the output layer, which produces the results, which could be the forecast or any other diagnostic test that you just previously performed. So the main components for AND, you have neurons, nodes. Neurons and nodes are the basic units that sit on the different layers, and they either receive the data, process the data, or produce the output. So on the input layer, the nodes receive the data. On the hidden layer, the nodes process the data, and on the output layer, the node presents the output of the data. So there are different types of neural network models. One type of neural network model is called the recurrent neural network model. This is a type of artificial neural network designed to process sequences of data, making it particularly suitable for tasks involving time series analysis and forecasting. Well, it can also be used for, like, let's say, natural language processing, speech recognition, and more tasks. Now, the key feature of the RNN is the memory. So what happens with an RNN? First, the data comes in on the input layer. Then the data is sent to the hidden layer. On the hidden layer, the data is trained in the model, and the model tries to figure out the pattern of the data. It produces an output. But before going on the final output and then the model right there, the output generated is sent back to the hidden layer and trains the model. So built in within an RNN, there's some kind of memory in terms of the model remembers what previous output was, what output was produced. It sends back the output in some kind of backward propagation algorithm. It retrains the model. The model tries to learn the pattern of the data using the old data as well as what it forecasted in the previous output. And this is used to help predict the output for any next layer of the overall model. Now, a special type of RNN is called a long short-term memory neural network model. So it's called LSTM, long short-term memory recurrent neural network model. This type of architecture is designed to address some of the limitations of traditional RNNs, particularly with regards to capturing and learning long-term dependencies in sequential data. LSTMs are well suited for tasks involving sequences such as natural language processing, speech recognition, forecasting, especially long time series, and more. The key features of an LSTM are memory cells. These are designed to store and access information over long sequences. So this is very appropriate for long time series. This is where you're dealing with thousands of observations. LSTMs also have gates. In fact, they use three types of gates to control the flow of information throughout the network. There's a forget gate, there's an input gate, and there's an output gate. The forget gate determines what information from the previous cell or state should be forgotten or should be retained. The input gate modifies the current input and decides what new information can be used to store in the cell gate. And of course, the output gate determines what information from the cell gate should be used to process the current output. LSTMs also have a hidden state or hidden level. So recall in a neural network model have three levels. There's the input, the hidden, and then the output. And in this hidden layer, there's a lot of processing of the data where the model tries to figure out the pattern of the data and so forth. There's the backward propagation. The backward propagation is where there's some kind of algorithm that sends back the output and it is used to train the overall model to figure out the pattern of the data. And this backward propagation is very effective in establishing learning, especially for long range dependencies. Now, there are significant applications for LSTM models. I only want to use this for time series forecasting. So in this video, I will show you how to use an LSTM model to produce a forecast or a time series. So let me share my screen. I'm guessing it here. All right, so we have Jupyter open up here. There's some code here. I previously ran the model and made sure it was working. So let's open up a new file. Let's rename the file. So basically, I'm using the LSTM model to forecast a time series. The time series that I was using was the Trinidad and Tobago rate exchange rate with the US. I already have the data. So the first thing we need to do is import the libraries. So this is the file with all the code here. I'm just copying and pasting the code. This is the code to run the LSTM model. So the first thing we do, we are importing the libraries. Of course, you know, we have to import pandas. We must import pandas because pandas is necessary to import the data. We need to import NumPy because this allows us to perform analysis on numbers. We need to import matplotlib. This is the geographs. We need to import sklearn because the neural network model will be run from the sklearn library as well as the TensorFlow library. So we imported these additional libraries for the model. Click here, run. See, we generated no errors, so we're sure this code is working. The next thing we'll do is import the data. So this is the file here. So this is the file here with the data. This is the real exchange rate. We are from January 1991 to July 2023. It is also important that you ensure that you have no spaces in the data because when we have missing data, they show up as non-missing values, NaN, and this could often lead to a problem when actually come to running the model. So this is a good practice when you want to run any kind of analysis in MATLAB or in Python or any kind of econometric software. Make sure you go through an Excel file sheet with the data and make sure you clean your data. Make sure there's no spaces, there's no missing data. Back here. So now we are importing the code. So observe I imported a lot of code here. Now, when I ran the code originally, my data was called WTI, but now my data is called RER, real exchange rate. So when importing data, make sure that you are, whatever forecast you want to run here, make sure you label it here. So if the data was RER, make sure this RER here. But if the data was, let's say, oil, make sure oil is here. Whatever time series you're working with, make sure you put in time series here. Otherwise, the code will not work. So This area here, you have to specify what is the time series or what is the variable you are working with. Whatever data is here should be the same thing here. It should be same thing here. And that's it. Oh yes, you can rename the data here. Let's rename it real exchange rate. And once you do that, the code should run. See, the model is running. And we generated a 10-step ahead out of sample forecast. So we're sure this thing is running. You see when I typed in this information here, this was a label. Let's change it back to RER price, just so you can see it. See, it's updated. So now time to perform some diagnostic tests. So the first diagnostic test we'll run would be the R squared, coefficient of determination, to determine the fit of the model. So usually after you run this model, just copy and paste this code and everything should work. I've not seen anything here to change. I mean, you could change yes, the label, but everything else will work. Run. This gives you the fit of the regression. This is another diagnostic, the response plot. Just click run. Everything should work. Well, we can see here, this is relatively bad results because we want the orange dots to be close to this red line as possible, but they're kind of off. So it's showing that the model don't really have a high predictive accuracy as we would like. So this is relatively a bad result. So we will reperform the goodness of the test, but we do it with confidence intervals. And this result is consistent with this result here. If you could see, this is the fit of the regression, something like a fit of regression line result from that. And this is the residuals. And we can see that these data points here are far from the residuals. These data points here are far from the fit. It's the same result we're seeing here. We're seeing this is the fitted model. This green line here is the actual data points. We see for this interval here, there's relatively a good fit. This gray area here is confidence intervals for the fit. So basically what they're showing is that if we run a regression, this is the fitted model here, and we are saying that we are 95% confidence that the actual value of the model should fall within this gray lines here. Okay, but if you look at the actual data is outside the gray lines for almost the entire time series. So it is showing that this is not a very good model. This model has a relatively low predictive accuracy. And in other words, or what happened in this case, the actual model, or in this case, the predictions are actually higher than the actual values. So the model can make it overestimating the point estimates. In other words, the model forecast is tend to be higher than the actual forecast then. So let's compute the mean squared error. This is the code here. So you can just copy and paste this code. This should work because once we already imported these different libraries, It should work. We already have the model. The mean squared error is low, which is relatively good. This is the code for the square root mean squared error. The root mean squared error is good. So say it all right. So what this means, right? So we get the mean squared error small. The root mean squared error is small. But we see in this line is some parallel. This showing that there's something wrong, slightly wrong with the model. In other words, there's like almost like a constant. Like if you just shift this line up, maybe by about 0.5, it will fall within this bands here. So there seems to be like a constant missing in the model. So the model not all that bad as all that. There's something that is causing the model to overestimate or produce estimates that are higher than actual value. But if there's a constant that shifts all the estimates, generally the model will perform good. At least this is what it's suggesting to me. So this suggests that just minor tweaks to the model is required to improve its predictive accuracy. This is the code for the Bland-Altman test. This is another diagnostic test. So generally how we interpret this test is that we have a line in the center here. This green line here and this green line is like, let's say the confidence interval. We have the data points here. And we can see for the majority of the model, the data points fall within the confidence interval, which is relatively good. But we've seen a few data points here are outside the confidence interval. This suggests to me that this model is not all that bad on it. This means that there's something wrong with the model, like a constant maybe missing or some kind of thing. We need something to shift the model, bring it down a little lower. And once we do that, the entire model will give us a good fit. So this is what suggests to me. So the model not as bad as how we were thinking originally, but there's room for improvement. So in terms of the output, remember the objective of this model was to run this model and produce a forecast. These are the forecasts right here. These are the point estimates of the forecast. So essentially, this is what we wanted. We wanted to run this model here. This is the actual model. This is the actual long short memory model here. We run this model and I generate this forecast. I generate these forecasts, and then everything we did afterwards with the diagnostic test to determine the predictive accuracy of the model. So this is relatively a short video showing you how to run a long, short-term memory neural network model. It's relatively simple. This code should work. You import the libraries, you import the data. The only thing you have to tweak in your code is this here. Make sure wherever you see RER, you change it with whatever is the name of your variable. So edit the code here. You edit the code here. You edit the code here. You have to look through, I'm not seeing anywhere else, but you have to look through the code, and everywhere you see RER, replace the RER with whatever is your name for your time series. And once you do that, the model should work. So I'll bring the video to an end right here. This is a video how to run a long, short-term memory neural network model in Python.